Okay, can everyone hear me? Good? All right. So, I'm Mike Walker, and this is my to-be-determined fill-in slot talk. Android, fragments, and services, oh my. 1 a.m. This Thursday morning, Wilbur's like, can you fill in a slot? I'm like, sure. So, that's how I'm here. So I'm going to go ahead and talk about a couple of side projects I have that are actually like intermediate steps to this grand scheme I have. And we'll get to that. I don't have too many sides, so if you have any questions or comments, raise your hands. There will be plenty of time. Don't worry. Because I don't feel like I'm going to eat up the full hour anyways. So, about me. I went to Youngstown State University, and yes, that is a pissed off penguin. So, that is our official mascot. Blah, 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 did well, and now I'm at Vanderbilt for my graduate degree, hopefully going on to PhD. So, first of all, let me just get some questions out of the way. Who here programs Java? Just show of hands. Who here can but doesn't want to program Java? Okay, there's more hands. Who owns Android devices? Wow. Okay. Other, we'll just skip. How about iPhone, just out of curiosity? Okay. No. Not for you. Who here programs Android? Okay. And who programs for the dark side? Boo. Yes. So, Android, good. I really, really enjoy and appreciate the design of the operating system itself. Much better security while allowing you to do things than any other operating system that I can really think of, because you have other extremes. Like Windows, you can do anything you want. There's no security. iOS, you do what they want, and there's minimal security. So inherently, there's good and bad things with Android, but at an OS level, I think they're going on the right track, and they're making improvements as new versions come out and things like that. So content providers. So those of you who program Android or you who have Android devices, you know your contacts. Any application can read your contacts. It reads it from a content provider. So that's the idea that they had. And if you give it permissions, they can read from a content provider. Same with background processes and services and stuff like that. Android's had those since day one. Oh, wait. I'm not making fun of Apple too much with these slides, am I? But yeah, so we're getting ridiculous resolution on Android devices, which I'll actually come to here soon. And near-field communication, which is something I'll get to maybe. But so these are concepts that have actually been adopted by the other major operating systems. As far as I can tell, Windows 8. Has anybody actually looked at the SDK or anything? Yeah. My understanding was they added content provider-like mechanisms. Okay, well, that was what they were going to do, so I don't know if they went that direction or not. I don't care, so I don't follow them. So, but here's my talk. Bad Android. What's bad about Android? Mainly, there's not good resources for Android development, at least what I would consider good. There's too many ways of doing the exact same thing, but they don't tell you the pros and cons of doing it a certain way versus doing it other ways. And I will show plenty of examples of that. No best practices book. This book, Rito Meyer, I don't know if, well, I just ripped it and it's not good. But Rito Meyer, he is the evangelist for Android at Google, and he wrote this is his second or third book on it, and it's a good book. It covers a lot if you're just getting into Android development. Oh, here's an activity, here's buttons, great. But if you're actually trying to do anything low level, like complicated with services or complicated content provider creation, just doesn't cover it. So there's no book out there for like a reference manual or anything like that that covers this type of information. I personally like those types of physical books when I'm coding. So, if any of you caught Doug Schmidt's talk yesterday, heavy use of software design patterns, which is good, but they don't talk about it and they don't explain them. So therefore, people have all these patterns available to them and they don't use them. So you see horrendous code snippets and just painful code examples online, when they could clean them up and make them literally more extensible and usable and make them make more sense. But they just don't do that. And Stack Overflow, great website. Horrible at answering advanced Android questions on there. They actually give you the wrong answer on a lot of things. They give, like the intro book type of questions, great. I mean, I have awesome answers, but I've found several just wrong answers up there, which if I had more time, I'd have to go up and fix, but I just haven't done that yet. So, like I said, the stuff I have issues with. Content providers. They're complicated and tons of boilerplate code that you shouldn't have to write yourself. Code generation should just do this for you. And we need better code generators for this because who here's written a content provider? No? Okay. It sucks. Let's just put it that way. And then there's a ton of ways of connecting to a content provider, but they're not really, like I said, they're not explained. So I'm fine. Okay, I sit down, I look at all like 12 or 8 different ways of connecting to a content provider. I can do the cost-benefit analysis because I understand operating system concepts and stuff like that, but most developers don't understand that, so they're just lost. I'll just use this, it works. Oh, it's 8 times slower than this method, but they don't know that. Services. Another one of this actually kind of got me upset, is people give horrible recommendations for what to do with services online. They're just wrong. It's kind of sad, to be honest, actually. But most of the recommendations just tell you to use handlers and be done with it because everybody knows handlers, and they're actually not the best. They're not the most elegant solutions, I'll put it that way. And then fragments. So fragments are this concept that they added in Android 3.0, and it allows you to have the same code that's dynamically loaded on the device based on what the screen is. So if it's a phone, you get one screen, one active area. If it's a tablet, you can have an active area over here and a second active area over here. So you could have a list of contacts, and over here you could see the contact. There's lots of examples like that. Kind of a steep learning curve. Like I said, almost EVE Online steep. So, but once you get used to them and once you learn them, they're amazing. They make your code instantly handle all types of like screen rotations and resizing, and they work on all the possible fragmentation of screen sizes and everything, and you write one set of code, you design it to be dynamic, and there you go, you're done. So, this is all the ways that I know of right now to connect to a service. So, just like in Linux world, because that's what Android is, you can have services. It has daemons and whatnot, but Android just calls them services. So runnables and handlers, messages and handlers. Runnables are, so you define your handler in your application code, and that handler handles messages and runnables. So it handles those by actually executing them in your application. So runnables are literally just code. So whatever the service decides it wants to do, it'll give the handler and it'll run it. So kind of dangerous if you're trying security issues, obviously. Messages are more of a enumerated, here's my API, I can handle these commands, and I'll parse your stuff, and I will build the actual runnable code based on these small list of commands. Works fine. That's what they teach you in the books, and it works. It's okay. But it gets really complicated and ugly code. So my preference is down here at the bottom. Oh, you can't see that. Well, the async AIDL model. AIDL is Android Interface Definition Language. So basically, you make a well, I can show you, but I'll do that here in a minute. But you make a definition of a class, called proxy actually, but of what the server interface is going to be and what the calling interface is going to be. And they can talk back and forth from each other asynchronously. And that's really good from a throughput standpoint, and they're non-blocking, and lots of good things that if you have any knowledge about operating systems and stuff like that, good, that's great, that's what I want. And then there's all these in the middle that are kind of hackish ways of doing them. And the async task with broadcast receiver is actually completely unsecure, and there's just different ways of doing it. But so the top two are what they recommend in books, and they have examples online. They work fine. But the bottom one, even sync AIDL, it's the same thing, but they're blocking calls instead of not blocking calls. That's the only difference. But that's obviously a big difference. So let's see. Yeah. Okay. Content providers. So like I said, a content provider is just it's just a data store type of mechanism. It's a public API that sits on the phone, and it has these, well, there's more, but these are the main 5 things that it has. Insert, update, delete, query, and content URI. Content URI is just a string, basically, that says, this is the content I store. And you can have multiple of those. I store this, I store this, I store this, blah, blah, blah. Most of it runs in an SQLite database on the actual back end inside the content provider. And all of this code is completely boilerplate. All you're doing is changing variables and adding them and doing low-level SQL inserts and all this stuff, which you can literally just script if you have a good template to start from. And unfortunately, there's not any good templates out there. Like, this is what you should do for anything other than a single table. So, yes?
I'll talk to you later about it. I mean, that's a non-issue with this particular example, the non-issue in Accelerator. They solved that. It's, I was kind of confused what you were talking about when we were talking earlier.
Well, yeah, the App Accelerator or whatever that's a different issue. That's sort of where this is going, but in a more, how do I phrase it? A more concise, less adaptable thing. So, yeah, you could extend it. It might be like a precursor to App Accelerator type of thing, but this is more of, you just want to write a quick code, here's my thing, I'm done. And I'll get to that here in a bit. So, where was I saying? Oh yeah, so you need to provide the standard API, insert, delete, blah, blah, blah. Has this ugly, ugly interface mechanism called content values. It's a tuple of 2 strings. Well, a string and something. So it's sort of like a hash, but not really. So yeah, it's a key value pair. And it works fine when you're doing it, but it takes a lot of code in the wrong place. So when you're the app developer, you want to pull the content value stuff out, or the values out of the content values. You have to do all these checking to see, is the values there? Are they the right type? And all this stuff. It adds a lot of checking code in the app side, which really shouldn't be there. It should be more in the content provider side. And there's no good way of doing that in Android. That's personal preference, my opinion at least. And how to make good URIs. Kind of a, you should just know this is what all the books pretty much say. Like, make them fit your data. Doesn't really work that well. And so another issue I have with the content providers is how to connect to them. It's not as bad as services. There's only, I believe there's the 4 right now, but I know they're adding at least one more in 4.2. So there's these 4 methods, these 4 ways of accessing content provider. They all have cost-benefit analysis and all this stuff. But even the Android website doesn't even touch on the cost-benefit of these. It just doesn't. I've ran some sample code, and the content provider client literally takes half as much time as the content resolver. And if you don't know how to write good tests and test that yourself or have the initiative to do that, you're not going to do that. You're not going to know. So you have people out there writing inefficient code, which they don't realize. So, oh, well, I covered most of this. But yeah, the SQLite full ACID database, blah, blah, blah. Everyone knows how databases work. And it's easy to make it in memory if you need really fast. It's easy to make it on disk if you need it for persistent storage. Don't store things over 50K, a big deal. And then the URIs and file URIs. So how to store files in a database is covered, but I haven't found good complex examples out there. So that's sort of one of the things I'm working on, is trying to find some good examples of how to store different files in different ways and all the different possibilities, do a cost benefit, show people, blah, that type of stuff. Yeah, I know. Well, oh, okay. Well, I wrote this without internet connection, so I was just pulling from memory on this part. Like I said, my cure for the ugly interface for content provider is these transport classes. This is actually, after reading it, close to what some of the other database storage libraries have done, but mine just uses a single class, and you write a couple methods, and you don't have to pull in another full library. So what it does is it's just a storage class for what you're going to transport. So whatever Java object you're going to put in and pull out of the database, it just has those fields. Then you implement parcelable and serializable. Really, you only need parcelable, but serializable is just for future extension if need be. It really, from the app developer standpoint, it really simplifies usage. Oh, okay, I have my blob of whatever. I'm going to store it in the database. Here, insert, and you're done. Works really well. It's really good from if you're writing code that you're going to be showing new developers or something like that. It simplifies the creation and insertion and stuff like that. So it logically keeps things more separate than it is right now. So you have one class per table and things like that. So this is for simple examples. It works really well. And I was just going to show you my code, but if nobody's an Android developer, okay. Where am I? Oh, fragments. One second. Oh, it's open. I'm just trying to get it to go to the screen. Sort of. JUnit, but you use a modified version of JUnit. So you actually install an application alongside. Come on. No. Yay for Linux. I have no idea why this isn't visible. I can't grab the top of it. Ah. There we go. Well, so yeah. So you install the application alongside of it, and that's the testing app that tests your app while it's running. It's really, really hard, actually. One of my coworkers is working on how to test services, and he spent almost a month trying to figure it out. It's because there's tons of things that aren't well documented. Like you have to be in a looper thread instead of a regular thread, which is never written anywhere if you want to test certain types of methods.
So in JUnit, does there such thing as the equivalency of a spy? Are you not able to, because in Jasmine, you're able to actually inspect inside an object while it's running, while it's instantiating, something called a spy.
Well, Java has reflection, and that's how JUnit works. On Android, I don't know how it pulls in and reaches. That's not really where I've been working, is the unit testing stuff. So I have that's cool. That sucks that you have to work that long to get it to work. And he's a good coder, so I'm assuming he's working well on it. It's just he's trying to test every aspect of complicated services, complicated content providers, and stuff like that. So.
Sure, going back to the talk last night, that's probably a design pattern that we researched or looked into, but that would probably solve the problem just entirely substantively.
Yeah, but so like I said, it's all I store is this is a simple example. It's a lat long, height, and user ID. It was a simple example application I was writing just for the heck of it, because longs don't need null checks, so it simplified a lot of my code. So I don't have getters or setters because actually in Android those slow things down. You're supposed to break OO and just read data directly from an object, which is kind of interesting, but hey, whatever. Yeah, I know. It breaks OO and that's bad, but this is like twice as fast. So just a constructor, blah, 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 toString for my own things. This is the content values. I actually store it somewhere else. I just use this as a redirect. I can show that. Android has this thing called Parcelable. It's a very, very, very fast version of serializable. Apparently, something like originally it was something like orders of magnitude faster, and then they realized their serializable was way too slow. So I think they've come closer, but this is much faster, and this is the only way to cross data objects between processes. So your data you're passing has to be inside a bundle, and the only way to be inside a bundle has to be the data has to be parcelable. It's just the rule that they made. And so you do this. All native types are parcelable, so you don't have to do this. But if you make your own custom objects, they have to be parcelable.
Is parcelable comparable to marshalling and demarshalling?
Yeah,
It's the same thing.
basically. So you put on the buffer thing. Well, this is just getting the content values, but if I come down here, I just return the content values. You put the name of the string, which that's kind of the hard part. You have to, if you're doing it in the code part, the developer has to be, I have to go pull this string from this library or this class, put it in here, use all this stuff, and you can hide all of that from the developer. Maybe that's an issue to you, maybe it's not, but to me, this cleans up the code a lot, in my opinion. So these are just constant, well, Java equivalent of constant strings, and it pulls the data in and makes a content value return. Okay. Let's see. Blah, blah, blah. Where is... Oh, that's why. I was in the wrong section. That's why. I was like, where's my code? Here it is. So the parcel destination, you write along, you write whatever the type is, and it just writes it to the information. And then it reads it too.
What's the function of this entire service? Is it just geolocation, or does it grab your longitude, latitude?
It doesn't do anything. You make up numbers when you enter them in the thing, and then it stores them. So it's not this isn't a real application that I use for anything. This was my example of getting the content provider, the database, all the fragments, which I'll get into, all of that straight. Because once you have a base application that's what you would consider best practices for your organization, how you think it should be, then you can just templatize it and make it to where you can change the data types, insert the whatever data you want to store, and you have a really, really quick app creation tool. And that's where I'm working towards, basically. And then also along the way, I'm keeping notes and stuff like that. So eventually here shortly, I'll put up my website, and I'm going to make a bunch of blog posts. I don't really like blogs, but make a bunch of posts about a lot of the complex, intricate things in Android that just aren't mentioned other places for whatever reason. So.
Do you find, or is there such thing as a difference APIs between different handsets? Like, do any particular handsets actually extend the API and the services per given handset? Do you find that typically doesn't exist?
I haven't seen it. So I'm working on a small subset of handsets, actually, for the research I'm working on. So, and we're still using 2.2. So the nice thing about this is the code hasn't changed at all. They've changed ways of accessing the content provider, but the actual content provider and all that stuff hasn't changed, and as far as I can tell, won't for a while. The Fragment stuff is new of 3.0, but they added a compatibility library. So the code, this code here, actually works all the way from 1.6 to 4.2. So it really makes your writing your code very adaptable and extensible, and you don't have to change it when a new version of Android comes out, or a new device or things like that. So, because it automatically changes, you can have it set to automatically change. Like I have a Nexus 7 here. When it's vertical or horizontal, you could have the list of whatever data type you're storing and a view. But on the Nexus 10, you could have a full list on the long side and two whatever you want on the top, and you just decide that based on screen width. And so if you make those decisions beforehand, even if you're not targeting a device that big, when one comes out, hey, look, my code, the exact code I wrote to fit in the small thing, I can program to basically be a plug-and-play module and work on the big screen. Works really well, actually. Yes, but you can detect that and already handle it. So what they added is, let's see. I can't do it. So here's this thing they added. Screen width, 600, whatever. There's my layout and values. It's kind of a blah way of doing it, but it works. Is it a tablet? It has over 600 pixels wide? Yes. Okay, I have a tablet display. So you could do one for TV. Is it over 10? Well, now with the Nexus 10, you can't really do that, but you could say TV density or whatever. You could have conditions, and you could find out where you're at just by this. This is a little thing they added. I don't know. I think 3.0, but it works really well actually. So you can change variables based on the type of device you're on, and then just read those variables and change your business logic behavior based on that. And you can do that in an entirely separate place then. Well, you change your UI logic in an entirely separate place, and you change your business logic. And so your business logic never has to touch your UI logic, which is the goal. Any other questions? Then him. Don't know. I really don't work with UI that much, to be honest. You can have multiple layouts based on the screen density and things like that. There's screen. I'm only using this one very small subset of ways of detecting screen size and things like that. Yeah, so these are relative to, I can't read them, but there's 4 of them. There's screen density, screen size, SUTs. So you just make your layouts the same as CSS. So you have it's this big here, and you go from there. And you can program in the layout itself to be, I want 2 columns, one of them 50% wide, the other 20% wide, or whatever. That's in the layout itself. This allows you to have multiple layouts based on screen sizes and stuff. So there's 2 ways of handling it. Well, one layout in every possible way you want it to lay out. So, but that's not even necessarily true, because it gives you enough freedom to detect if your screen width is over 600 pixels. And so yeah, but this will detect either way. If the Nexus 7, it'll detect either way that its tablet is true. That's irrelevant of total height width is over 600. They keep it a constant on the device specifications, and then orientation is entirely different. Your current orientation is a different subset of that. So there's lots and lots and lots of ways you can get really advanced and tricky with the UI. And I'm not a UI person, so I just make rows and columns, and yeah, it looks good. I don't care. It's functional. Here, somebody else make it look pretty. So, any other questions? No? Yeah? Oh, okay. Whatever. I'll leave that there. So, like I said, fragments. It's dynamic UI fragments of code. Enables the same code to work on multiple phones, TVs, things like that. Interchangeable. Oh yeah, can't have fragments inside fragments, but you do. So that's their first thing is you can't have a fragment inside a fragment. Sort of. You can't have a fragment inside a fragment the normal way they teach fragments. But you can have a fragment that doesn't display UI inside a fragment. And what that seems a little odd at first. But what that does is fragments have a life cycle different than activities. So an activity goes away, you go to another activity, you come back, you can do all these things. Fragments live outside of that. So your activity can go away or be hidden and destroyed, or paused while your fragment is still in existence and can be doing long synchronous or asynchronous calls to a service or downloading a file or things like that. You come back to your application, hey, look, the state changed to what I thought it should have been, even though the UI was technically paused and not killed, but not active. So you can do all these things with a fragment that doesn't store, show, or use AI or UI. No, fragments are in the main, what's called the main UI thread. So, yeah, like I said, I kind of want to slap Rito Meyer because he works at Google. He could have made a great chapter on this. He has a couple pages, and he doesn't really explain any of the detailed stuff. The only single place I found a good example of how to store state when you change, when you change rotation, your activity gets killed, and then you have to recreate your activity. But if you have a fragment that's existing, your activity gets killed, your fragment's still alive, you can restore state from your fragment, even if it doesn't have a UI, and then recreate your UI with the rotated screen, and it's consistent to the user. So it's a really good way of storing state between changes of the handheld or whatever. I'll show code. No, I won't. But I'll show a little bit. Okay. Here's just a view location. So it, whoops. Sorry, can't see the screen well from this position. It has 4 text views that are on this screen that it doesn't touch, and then 4 text views where it changes the text on them based on whatever you pick from a drop-down list. And on-click listener, blah, blah, blah. If you know Android, that's no big deal. Housekeeping. So here's where it creates the actual UI. It just goes and pulls the UI fragments from the layout XML file, connects them to local variables. That way you can manipulate them. So you get them, store them, and then you set on-click listeners for the buttons. Nothing too extravagant. This is really not that detailed of an example, but you get the idea. And so then you just set your text. And that's it. And this code, this fragment, multiple UIs can put this in wherever you want. So you're leaving your UI development team or person, or when you're going to do it yourself, to another time. So you have the logic there, and it works fine. You can hand it off, and the UI person can just take it, modify it, make it look however they want, make it look nice and pretty and sparkle, and have a Nan, not Larry on it, or if you have Will Pig developing it, whatever. Yeah. So here, like I said, I hate UI. I hate designing UI. I'm taking I'm at Vanderbilt, so I'm taking the Doug Schmidt course on advanced operating systems, and we're using Android as our operating system this time. And I am able to do the hard part of the assignment within like 30 minutes to 2 hours, depending on the assignment. I spent a couple weeks on the UI. So it's just because there's lots of little gotchas types of things. So this idea is a contract. It's a script input file to your generator that I'm working on. Contract would describe the data that you're trying to store and display and read and that type of stuff. So in this previous example, it would have said long, longitude, height, and user ID, whatever. And so you just create this XML file. You can use a UI to do that if need be. And then you can hit generate, and it'll generate all the hard code that the back-end code and some of the front-end code from a starting point. This isn't going to finish your application for you by any means, but it gives you a good example of, okay, this is how I should do this. This is a good practice. Here's how to use builder or factory methods, things like that. So patterns. It shows you good uses of the patterns, how you should do them, how you should extend them if you need to, things like that. And then, so another project I'm working on besides that is the dynamic UI, which, so your UI is an XML file, but you have to compile that when you install it on the device. And what I'm working on is actually basically the exact same XML file. You can send it to the device as a mechanism. You get it on the device, however you do that, through content provider, sync adapter, tons of ways of doing it. And so you can update the UI, how it would look on the device without having to reinstall the application. So it would really speed up UI development. So mixing these things together, you can go that way. You could even, theoretically, if you wanted, in the future, if I actually get this off the ground, fix typos and things like that through just sending out. If this was a corporate environment, it'd be easier. But you send all your devices an updated XML file saying, oh well, the cancel and blow up the ship button I reversed. So you just swap them and there you go. No big deal. You're done. You don't have to reinstall the application on all the devices, which you could probably do is scripting-wise, but I'm kind of just playing around, and I think it's a cool idea, so I don't care. No, I think it's cool, and it has possibly potential. I don't know. It's still at the testing stage. And so I covered this. So you just push it out, the XML, blah, blah, blah. You don't have to deal with this. And so CRUD, why the create, read, update, and delete thing. Everybody knows it. It's useful. It's a good starting point. It's a good, if nothing else, it's a good testing point. So you could make, if you're making the back end for your server, you could make, okay, well, I'm going to be getting these things, these whatever you're making, these data pack blobs, and here, I can make a bunch, I can send them, and there we go. You just make the quick application that just you can store a bunch of them, and then if in the future I want to do some type of networking in this too, so you can send them to a server or whatever, have different options, configurations, things like that. And so that's sort of like the best practices, fragments, and whatnot. I'm trying to pull all those together and into a nice, clean, simple app to allow fast, rapid development of simple Android applications that have actual usability for either testing or a foundation to build your application on top of, things like that. I'm going to skip these, running out of time. No big deal. I made a tiny URL. If anybody wants this book, it's there, and my website. So I'll be posting a bunch of code snippets here after the semester because I don't have time right now. But yeah, there's my website. I'll be trying to put these up, all these projects up there on Git repos and things like that, so people can look at them, check them out, give contributions if they want, you know, that type of stuff, and then we'll go from there. And then all my images. Any questions, comments, concerns? Want to give me monies? No? Okay. Yeah, that's one. I have a couple different parts that one I have it working and it does work, but only for a very a button, a text view, and an edit text with no styles whatsoever. So it's kind of useless at this point, but the technology, the logic there works. So if I get time, I could expand it to include like relative layouts and all that jazz. Possibly. I haven't really gotten to that point yet, but that's one of the ways. Or you could, in the logic code of it, have it the application know to change the layout in certain ways. So, but probably pull the URI is the best one. I haven't gotten that far, so I really haven't put too much thought into that part yet. But yeah, probably. But that would be more of I'm going to deploy this on a single type of device to a lot of people, where I would see that being really useful. So if your corporation or your company has Nexus 7s or 10s that it gave out for company use for whatever reason, or because I know Vanderbilt Medical Center is using iPads. Unfortunately, no. They're using iPads for monitoring of the rooms to see if anybody's in them. So you can look, they can control the camera and stuff like that. So. Pretty much, yeah. And that's the idea of how Android separates the UI from the logic, but they end up creeping into each other often. So, and this is just a fast way of doing it. Any other questions? No? Okay. Well, thank you very much. I guess I'll show this. This is my simple CRUD example for that. You can edit it, whatever, delete it. There you go. And on a tablet, I can show you. I have no idea how to get a tablet virtual machine emulator on the computer. So, but I can show you. It shows the two UIs next to each other instead of one at a time. So you have the list on this left-hand side that's always constant, and the right-hand side changes. Thank you.